My name's Adrian Fox. I'm the lead plant virologist here at Fera. I lead the plant virus diagnostics team, which is responsible for testing plant virus material at import and export to the UK, but we also test in support of potato seed certification, but we also offer a commercial service for virus testing across the whole range of plants that are grown within the UK. The main reason that we will be testing tubers for the presence of viruses is that viruses can seriously impact on the yield of potatoes that you'll get back from your field. So that would either be straight reduction in yield, so you would get fewer tubers or you get smaller tubers, or it can be the impact of surface blemishes and cracking that will then lead to a lower marketable yield. At Fera, we have two ways of testing tubers. We can either do a direct molecular test or we can do a grow-out test. To support the grow-out test, we have glasshouse facilities, and we also have the ability to do serological testing on the tubers that have grown out. For the molecular testing, we have a full suite of molecular diagnostic labs where we use what we call PCR machines, and we can test directly on the tubers to see how much virus is present within the stock. So in terms of comparing the growing out test and the direct molecular test, the two tests are comparable. You may get slight differences in the results due to sampling differences. However, in terms of the tests themselves, what will be picked up by one test would also be picked up by the other, and the results would therefore be comparable. And here at Fera, we do routine validation testing to make sure that those two test results would be comparable with each other. In the laboratory, we can only test the sample that we receive, and we have to make sure that that sample is as representative as possible from the stock that's been sampled. The best way to do that is to take the 120 tubers that we require after burn down and before harvest, and if you take that from a W pattern across the field, taking one tuber per plant that you sample, and that will make sure that the sample is representative. If it's not possible to sample from the field, you can sample from boxes in store, but again, please make sure that that's a representative sample, and we would recommend taking one or two tubers per box sampled, up to about 10% of the total number of boxes from a crop, rather than just taking all of your 120 tubers from a single box, which would not give you a representative sample. Once those tubers arrive at the laboratory, depending on whether you're having the growing on test or the molecular test, they will get dealt with slightly differently. So for the growing on test, we remove the growing eye plug from the tuber. We then treat that with a sprout promoter called gibberellic acid, and that then causes the plantlets to grow. And after 4 to 5 weeks, we will test those resulting plantlets. And what we're effectively doing is bioamplifying the virus that's present within the potato tuber to give us a reliable source of detection, because the method we use, called ELISA, which is a serological method based on antibody detection, lacks some sensitivity. It's still a good, robust method, but you need the bioamplification to make it robust. For molecular detection, we would actually take plug from the heel end of the tuber, so the stolon attachment point where it attaches to the mother tuber, and that would then be tested in bulks using a nucleic acid detection method that effectively detects the viral nucleic acid, or the DNA, and use that to identify how much virus is present within the sample. In terms of the impact of viruses on tubers, first and foremost would be the yield reduction. So smaller tubers, fewer tubers per plant. And if you look at the literature, it would give you figures up to 85% yield reduction. In reality, in a field, you will get a compensatory effect where the potatoes growing around an affected plant will actually have more available nutrients, so will produce proportionately more tubers. There was some work done in the US about 10-15 years ago that actually quantified the yield reduction due to potato virus Y, and they showed that on a crop of potatoes you could expect to get about a 0.2 tonnes per hectare reduction per percent virus infection. So if you have 10% virus infection, you would expect to get a 2 tonnes per hectare yield reduction. So over and above the straight reduction in yield, you would also possibly see that some varieties are particularly prone to surface blemishes or to cracking. There's been work done to show that mosaic diseases such as PVY, PVV and PVA can lead to an increased growth cracking in tubers from affected plants, but also you will see surface blemishes, and we know that there are certain strains of potato virus Y that are linked to surface tuber necrosis, or what we call potato tuber necrotic ring disease, and again that can render your yield unmarketable. So one of the main identifiers of whether a crop would be at a high virus risk or not would be the presence of vectors or the aphids that transmit the viruses. And to help to quantify whether your crop is at risk, we also run a yellow water trapping service. So you can put yellow water pan traps in the field. Those can be used to actually catch aphids, and then we can bring those traps back here and we can identify and quantify what aphids are present. And the turnaround time for that service is literally a 24-hour turnaround time. What we would look to do is to see when those populations are building and when the migrations start. So we would look to be identifying when the populations are really starting to take off exponentially and try and identify that key point for virus control. And that can help give you a traffic light to quantify whether or not your crop is at risk from virus. There is a general trend in the amount of virus we see. Across Europe, we're seeing virus levels increase in potato tubers generally, and certainly last year was a particularly bad year for high virus levels. Some of that is due to different varietal susceptibilities, and some of it is due to the particular relationship between the virus strains and the varieties and how they specifically interact.